The moon is drifting away. Yes, our natural satellite, the one that lights up our nights, controls the tides, and has been the stage for humanity's greatest dreams, is slowly moving farther from Earth. Every year, it slips away about 3.8 centimeters. It may sound small, almost meaningless, but what if I told you this subtle motion could trigger a chain of catastrophic changes? Not tomorrow, not in the next century, but in the slow rhythm of cosmic time. Have you ever stopped to think what our planet would be like without the moon, without its regulated tides, without its gravitational force stabilizing Earth, without the silver glow that inspired cultures, calendars, and myths? What happens if the moon keeps drifting away? What exactly will change for us? Today, you'll discover how the moon is shaping Earth in more ways than you imagined, and why its departure could mark the beginning of something dark. It's almost imperceptible, but it's happening right now. The moon is drifting away from Earth. Inch by inch, year after year, our natural satellite is on a slow, silent escape trajectory. A cosmic dance that began billions of years ago, and still continues. But why is this happening? What's causing the moon to slip away from Earth's gravitational grasp? And what does it mean for our future? The explanation begins with something deceptively simple. The tides. The moon's gravity pulls at Earth's oceans, creating high and low tides. But this isn't just a coastal curiosity. It's the key to this gradual separation. As Earth spins, it drags the tidal bulge caused by the moon slightly ahead of the moon's position. That's where things get interesting. This offset creates a forward pull on the moon, adding energy to its orbit. As a result, the moon gains orbital energy and slowly spirals away from Earth. Meanwhile, Earth loses rotational energy, meaning our days are getting longer. Today, scientists estimate that the moon moves away from Earth by about 3.8 centimeters per year. It may not sound like much, but over millions of years, this small drift has huge consequences. Travel back 1.4 billion years, and Earth's day was just 18 hours long. That's because Earth was spinning faster, and the moon was much closer. Every century, our planet's rotation slows by about 2 milliseconds. At this rate, far in the future, a day on Earth could last more than 30 hours. This energy exchange between Earth and the moon is known as tidal acceleration, and it's not just a theory. We have direct proof. In 1969, the Apollo 11 astronauts left a retroreflector on the moon's surface. Since then, scientists have been firing laser beams at the reflector and timing how long it takes for the light to bounce back. This gives us the exact distance from Earth to the moon, accurate down to the millimeter. The results confirm it. The moon is indeed drifting away, but it won't drift forever. In a future so distant, it's hard to imagine. Billions of years from now, Earth and the moon will become tidally locked to each other. Earth will rotate at the same rate the moon orbits. Just as the moon already shows only one face to Earth, Earth will always show one face to the moon. Days and nights will change forever. Tides, too, will become still, predictable, or even fade. This might seem like a scientific curiosity, but the consequences are deep. Tides play a vital role in ocean life, weather patterns, and Earth's climate. A shift in this balance could transform ecosystems across the globe. Even more, the moon's slow retreat alters the angular momentum of the Earth-Moon system, a physical property that helps scientists reconstruct Earth's past. By studying it, we gain insight into glaciation cycles, axis shifts, and even how oceans and continents evolved over time. So yes, the moon is slipping away, slowly, invisibly, but surely. And that motion, seemingly trivial, is shaping the very rhythms of our planet. And perhaps the most incredible part? We can measure it. From a spinning planet orbiting an average star, we fire lasers at the moon and detect a tiny, steady drift. And this is just the beginning. The moon is much more than a bright point in the night sky. It is a fundamental and constant force acting on Earth with almost choreographed precision. Although it is about 384,000 kilometers away, its effects shape oceans, stabilize the planet, and influence even the behavior of life. Its impact begins with gravity, a subtle yet powerful force. The gravitational interaction between Earth and the Moon is so significant that, without it, our planet would likely be hostile, unstable, and perhaps even uninhabitable as we know it. The most visible influence of the Moon is the tides. But calling the tide's simple rise and fall of the water is a gross oversimplification. They are complex planetary movements involving interactions with Earth's rotation, the Sun, and even the deep oceans. Lunar tides help to distribute thermal energy across the oceans, acting as a natural climate regulator. They drive coastal currents that nourish marine ecosystems, transport nutrients, and oxygenate deep waters. Without them, many coastal regions would be dead ecosystems. The ebb and flow of the waters also shape the land's coastlines, sculpting peninsulas, cliffs, islands, and estuaries. And most impressively, tides act as natural clocks for countless forms of life. Some animals, like mollusks and crabs, have timed their biological cycles according to the tides for millions of years. Their life beats are attuned to the pulse of the sea, which, in turn, pulses to the rhythm of the moon. The tilt of Earth's axis is responsible for the seasons. Without the moon, this axis would oscillate violently, potentially changing in a matter of thousands of years, altering climates and ecosystems unpredictably. With the moon, the axis tilts smoothly between 22.1 degrees and 24.5 degrees, in a cycle of about 41,000 years. This oscillation, called nutation, has a direct impact on global climate over geological eras. This stability allowed glaciations and interglacial periods to follow a rhythm that life could keep pace with. Simulations suggest that, without the moon, Earth's axis could sweep to angles of up to 85 degrees, causing the poles to receive direct sunlight during certain periods. This would turn Earth into a chaotic world, with extreme heat and cold where there was once balance. In this context, the moon acts as a gyroscopic stabilizer, keeping our planet aligned and conducive to life. It's as if it were a silent mother, holding steady the restless child that is Earth. From marine life to human beings, the moon shapes biological rhythms on an astonishing scale. Some coral species only reproduce during specific phases of the moon. Sea turtles wait for specific moons to lay their eggs. Even the human menstrual cycle, with an average length of 28 days, is often associated with lunar cycles. Lunar influence is so ancient that lunar calendars were used by civilizations such as the Sumerians, Egyptians, Mayans, and Celts. In many cultures, the moon governed festivals, harvests, wars, and ceremonies. It was a universal time marker, even before the invention of writing. While modern science remains skeptical about direct lunar influences on human behavior, recent studies have shown subtle correlations between lunar phases and patterns of sleep, mood, and even criminal activity. A field still under debate, but intriguing. Beyond all of this, the moon plays an almost forgotten role as a celestial protector. Its gravity helps to moderate Earth's orbit, preventing it from suffering perturbations caused by Jupiter or other massive bodies in the solar system. Without this balance, our planet could be sent into a chaotic trajectory or experience orbital shifts that would affect its climate for ages. Physically, the moon also absorbs cosmic impacts. Its countless craters are testimonies of thousands of collisions that could have struck Earth. It functions as a stone shield, silent but crucial. In 2013, a meteor struck the moon with enough force to be seen from Earth as a bright flash. Had this object come toward Earth, the damage could have been severe. Events like this are more common than we realize. The moon's relationship with Earth is not limited to tides or stabilizing the planet's axis. It also plays a crucial role in shaping Earth's climate and weather systems, influencing everything from winds to rain patterns, and even long-term climate stability. While the sun is obviously the primary driver of Earth's weather, the moon's gravitational pull and orbital mechanics work in tandem with the sun's power to shape the rhythms and fluctuations of our environment. The moon's gravitational pull has a less obvious but still significant effect on Earth's wind patterns. While the primary drivers of wind are solar radiation and Earth's rotation, the moon's gravity interacts with Earth's atmosphere in ways that are still being explored. Some studies suggest that the moon's gravity influences atmospheric pressure systems, triggering subtle shifts in wind direction and speed. For example, the lunar-induced tides in the atmosphere can create pressure gradients that, in turn, alter wind patterns. This lunar influence is most apparent in high-altitude winds, where pressure systems seem to correspond with lunar phases. The moon's pull also impacts monsoon cycles, as the shift in atmospheric pressure can influence the seasonal winds that bring heavy rains to some regions of the world. Beyond just causing ocean tides, the moon's gravitational forces may also affect precipitation. The most notable of these effects is the moon's subtle influence on weather systems. Some researchers have pointed out that the moon can play a role in influencing rainfall, even if only in very minor and often imperceptible ways. One example of this is the moon's influence on cloud formations. During certain lunar phases, the moon can slightly increase the amount of moisture in the atmosphere, affecting cloud condensation. This can lead to increased precipitation in some areas, especially in regions that are already predisposed to rainy seasons. These effects are much more subtle than the gravitational forces that drive ocean tides, but they serve as a reminder that the moon is, in fact, a driving force behind Earth's weather system, even if it's in ways that we can't easily perceive on a day-to-day basis. One of the moon's most fascinating contributions to Earth's climate is the way it influences seasonal patterns. While we typically associate the changing seasons with Earth's tilt and orbit around the sun, the moon's gravitational forces play a secondary but still important role in regulating seasonal weather patterns. For example, the moon helps to regulate Earth's polar climates, particularly at the poles. By stabilizing Earth's axial tilt, it helps prevent extreme seasonal fluctuations that could lead to temperature extremes or unbalanced weather patterns. This effect is crucial for maintaining relatively stable climates on Earth and making it hospitable for life. The lunar cycle's influence on seasons may also affect the timing of seasonal changes. While the exact mechanisms are still being studied, there is evidence to suggest that the lunar cycle could influence the timing of plant growth, animal migrations, and even weather events such as snowfalls and heat waves. Though the moon doesn't directly create storms or cyclones, it can influence their formation. The gravitational effects of the moon have been linked to certain atmospheric conditions that can create the right conditions for storm systems to develop. In particular, during certain lunar phases when the Earth, Moon, and Sun align, the moon's gravitational influence can contribute to higher than usual tides and increased pressure on the atmosphere. This, in turn, can enhance storm systems, triggering cyclonic activity, particularly in tropical regions. There have been instances where the moon's tidal effects have coincided with weather events, intensifying the development of tropical storms, or hurricanes. These alignments, though rare, show just how deeply interconnected the lunar cycle is with the Earth's weather systems. Over geological time periods, the moon's influence has played a crucial role in regulating Earth's climate. By stabilizing the axial tilt and moderating the planet's orientation, the moon has prevented drastic changes in Earth's climate, such as runaway ice ages or extreme global warming periods. The moon's gravitational pull has also helped to stabilize Earth's orbital eccentricity, preventing wide oscillations that could have caused massive climatic shifts. Without the moon's stabilizing influence, Earth's climate could have been far more volatile, perhaps making it impossible for life to develop in the way it has. Moreover, the tidal energy produced by the moon's influence has caused slow but steady changes in Earth's atmosphere over millions of years. As the moon's orbit gradually pulls away from Earth, this effect is likely to continue, though it will take billions of years before the change is significant enough to affect life on Earth. As we've seen throughout this journey, the moon is far more than just a shining rock in our night sky. It is a key player in the evolution of life on Earth, shaping everything from tidal rhythms to biological cycles, and even influencing the stability of our climate. The deep and enduring relationship between the Earth and the moon has been essential for the development of life as we know it, and it will continue to affect the planet for billions of years to come. The next time you look up at the moon, remember, it's not just a distant celestial body, it's an integral part of our existence. Its gravitational forces have shaped the course of our planet's history, and its pull will continue to guide the cycles of life, ensuring the sustainability of Earth's ecosystems. If you enjoyed discovering how the moon influences life on Earth, don't forget to subscribe and hit the bell icon to stay updated on all things space. Share this video with others who are curious about our fascinating lunar connection, and join us next time as we explore even more mysterious phenomena in the universe.